Hi. So, in case you're a little rusty with long division, let's just quickly revise what this means and how it's done using an example. Right, so, what is long division? Well, long division is an algorithm for solving the following problem. Right. So, we have two polynomials, p and q, and the degree of p is greater than or equal to the degree of q. Right, so if the degree of q is, say, 3, so we have an x cubed term in q, then we will have an x cubed or an x fourth or any larger power term in p. Right. Now what we want to do is the following. We want to find polynomials k of x and r of x with the following properties. Firstly, the degree of r is less than the degree of q, and you can write p of x over q of x as k of x plus r of x over q. Right, and k is going to be called the quotient, and r is the remainder. Right. Now, how does this work? Well, let's look at an example. Right, so we have p of x over q of x. P is this polynomial, x to the fourth plus 2x cubed plus x minus 1. And q is x squared plus x plus 1. Okay. So, let's write, this is our divisor, this is our numerator. Right, so we're going to divide by x squared plus x plus 1, and we're dividing x to the fourth plus 2x cubed plus x minus 1. Right. Now, how do we start our algorithm? Right, so algorithm, remember, is a recipe. Right. So we start our algorithm by taking the term in p with the highest power, it's called the leading term, and dividing it by the leading term in q. So we're going to take x to the fourth and divide it by x squared. Right, and that's going to give us x squared again. We write that on top. Now we multiply x squared with q. Right? And we write it down here. So x squared times q will be x to the fourth plus x cubed plus x squared. Right. And we subtract the answer. Right. So we're going to take this polynomial here that we get by multiplying this quotient with x squared plus x plus 1 and subtract it from p. Right. You'll see immediately what will happen is the leading term will fall away. So the highest power is going to go away. Right. So what we're left with x cubed, right, minus x squared plus x minus 1. Yeah. So now we have a polynomial with degree lower than what we started with. Right. And we repeat the process. So we do this again. We are using this polynomial. Right, so we take the leading term here, x cubed, we divide it by the leading term in q, x squared. Right, so it's going to be x cubed over x squared. It's going to give us x, so we add it there, and we multiply in again. Right, so we take x and we multiply it with x squared plus x plus 1. And that'll give us x cubed plus x squared plus x, right, and we subtract. Right, so the x cubes fall away, we get minus 2x squared. Right. The x's fall away, we have a minus 1. Right. Now we're going to continue this process until the degree of our answer here is lower than the degree of the divisor. Right, so now we have an x squared and an x squared, so we're not quite there yet. Right, so we again take the leading term there and divide it by the leading term in q. So we take minus 2x squared, we divide it by x squared. That gives us minus 2, and we multiply in, minus 2x squared, minus 2x, minus 2, and we subtract. Right. So the x squared terms are going to go away. We'll get 2x plus 1. And now we stop, right? Because now we have the degree here being lower than the degree in the divisor. Right, so if we divide here, we're going to get a 1 over x there. Right, remember we just want polynomials, so we stop. And we're done. And so what we have here, top, that's our quotient, k. And what's left here at the bottom, what remains, is the remainder. Right. So you can then write P over Q as k, the quotient, plus R, the remainder, divided by Q.